In this section, we'll review finding the zeros of a polynomial, finding the x and y intercepts, finding the vertex and the axis of symmetry of a quadratic function. So let's start with finding the zeros of a polynomial. So the zeros of a polynomial are the place where the polynomial touches or passes through the x-axis. Zeros and x-intercepts are synonymous. So whenever we're finding the zeros, we want to make sure that the polynomial or the function is in its factored form, and in the first example it is. So all we need to do to find the zeros is to set each factor to 0. Well, we know 4 is a constant, so it can never equal 0. We also set x plus 5 equal to 0, and then x minus 6 equal to 0. You notice that x minus 6 has an exponent of 3. You'll deal with the concept of multiplicity later on. So let's go ahead and just finish this problem. So all we need to do in this case is solve each equation. So we're going to subtract 5, and that gives us x equals negative 5 is one of our zeros. And our second zero, we're going to add 6. So our second zero is a positive 6. So for this polynomial function, we have 2 zeros. The next example, we're asked to find the zeros of f of x equals x cubed plus 2x squared minus 9x minus 18. So we need to put it in its factored form first. So we have 4 terms, so we're going to factor by grouping. So we're going to put parentheses around the first 2 terms and around the last 2 terms. So we're going to look for the greatest common factor of x cubed plus 2x squared, and that would just be x squared. So we factor out the x squared, and that leaves us with x plus 2. In the second grouping, we have negative 9x minus 18. So the common factor of 9 and 18 is 9. And since there's a negative in front of the 9, we're going to factor out a negative 9. And so we divide negative 9 out of each one. So negative 9x divided by negative 9 is positive x. And negative 18 divided by negative 9 is positive 2. And remember, the values inside parentheses need to be identical, and they are. So x plus 2 is the greatest common factor. And our 2 factors on the outside of the parentheses make up our other factor. Now keep in mind, x squared minus 9 is the difference of squares, so we can factor that further. So our factors would be x plus 2, x plus 3, and x minus 3. The x plus 3, x minus 3 is the factored form of x squared minus 9. So now to find the zeros, we set each factor equal to 0 and solve. So we set x plus 2 equal to 0, x minus 3 equals 0, and x plus 3 equal to 0. And we solve. So our first 0 would be negative 2. Our second 0 would be positive 3. And our third and last 0 would be a negative 3. Our next example asks us to find the x-intercepts for the graph of the quadratic function. So in this case, again, zeros and x-intercepts, we need to make sure that we factor. So 2x squared minus 7x plus 3, we need to factor using the AC method. So again, to review the AC method, I'm going to take the 2 and multiply it times the positive 3. And that gives me a positive 6. I'm looking for the 2 factors of positive 6 that add to my middle term, which is a negative 7. So I know that negative 1 times negative 6 equals positive 6, and I know negative 1 plus negative 6 equals negative 7. So I'm going to rewrite the expression using those 2 factors to rewrite the middle term. So now I have 2x squared minus 1x minus 6x plus 3. And just as we did in the previous problem, we're going to factor by grouping. So I grouped the 2x squared minus 1x, and I grouped the negative 6x plus 3. So in the first group, the common factor is x. So when you factor out an x, that would leave you 2x minus 1. And in the second, the common factor of 6 and 3 is 3. And since there's a negative in front of the 6, I'm going to factor out a negative 3. So you're going to divide negative 3 out of each term. So negative 6x divided by negative 3 is positive 2x. And positive 3 divided by negative 3 is negative 1. Again, the value inside parentheses has to be the same, and it is. So 2x minus 1 would be our common factor, and x minus 3 would be our other factor. To find the x-intercepts, we set each factor to 0 and solve. So we'll add 1 to both sides and then divide by 2. So one of our x-intercepts is 1/2. And for the second one, we're going to add 3 to both sides. And our second x-intercept is positive 3. Now to find the y-intercept, we'll do a problem to review finding the y-intercept. So the y-intercept is the place where the graph passes through or touches the y-axis. To find the y-intercept, we set x equal to 0. So all we're going to do is substitute 0 in for our x's. So this becomes 0 squared plus 3 times 0 minus 2. So 0 squared and 3 times 0 are both 0. So we have 0 minus 2, and 0 minus 2 is minus 2. So the coordinates of our y-intercept, since we substitute 0 in for x, would be 0 and negative 2. Now we're going to find the coordinates of the vertex. Just to review the concept of a vertex, the vertex is the lowest or highest point of a parabola. So if our parabola is facing up, our vertex is our lowest point. And if our parabola is facing down, our vertex is our highest point. Now we also talk about the axis of symmetry. What is the axis of symmetry? The axis of symmetry is an imaginary line that divides our parabola into two identical parts. So if we have a parabola, the axis of symmetry would be an imaginary line passing through the vertex that would divide our graph into two identical or symmetrical pieces. So let's talk about the process of finding both. So in this case, we have f of x equals x squared minus 10x minus 7. So to find the x value of our vertex, we use the formula, the opposite of b over 2a. So when we look at our function, x squared minus 10x minus 7, the value in front of x squared is 1, so we have a equals 1. The value in front of x is negative 10, so we have b as negative 10, and c equals negative 7. In this problem, since we're finding only the vertex and the axis of symmetry, we just need to use the a and the b. So to find the x value, we use the formula the opposite of b. So the opposite of negative 10 is positive 10 over 2a, so that would be over 2 times 1. So x would equal 10 over 2, which equals 5. So the x value of our vertex is 5. Well, the equation of our axis of symmetry, remember the axis of symmetry is a vertical line, so it's going to be x equals, and it equals the x value of our vertex, which we just found to be 5. So that would be our axis of symmetry. Now we need to find the y value of the vertex. So again, our vertex, we found the x value to be 5, which again is our axis of symmetry as well. And now we need to find the y value. So what we do is we take the x value and plug it into x in our original function. So to find our y value, we plug in 5 for x, so this becomes 5 squared minus 10 times 5 minus 7. So this would be 25 minus 50 minus 7. 25 minus 50 is negative 25 minus 7, which would be a negative 32. So our vertex would have coordinates of 5, negative 32. So now we have a parabola in the form f of x equals the quantity x plus 4 squared minus 8. So we're asked again to find the vertex and the axis of symmetry. So in this case, it'd be more advantageous to use our transformation. So let's look at the transformation for this particular graph. So remember, our parent function has a vertex of 0, 0. So in this case, we have both a horizontal shift and a vertical shift. So what's going to happen in this case, since we have x plus 4, our graph is going to shift 4 units to the left, not the right, to the left. So our vertex is going to shift 4 units to the left, and then 8 units down. So from our original graph, our parent function at 0, 0, our graph shifts 4 units to the left, then 8 units down. So the coordinates of our vertex would be negative 4 and negative 8. Again, a shift to the left 4 and down 8. So what's our axis of symmetry? Remember, it's the x value of our vertex. So the equation for our axis of symmetry is simply x equals negative 4.